afternoon, ladies and gentlemen. Welcome to the second session of this Global Networking Forum. This session is on scientific robotic exploration of the solar system. We are pleased to have Deputy Director of the Chinese Astronomical Observatory in Chunlai to deliver a presentation for us. Director Li is the Deputy Chief Designer of China's first Mars exploration mission. He also leads the discussion and development of scientific objectives for the Chinese deep space exploration plan. He's going to talk about the development strategies and scientific objectives of deep space exploration in China. Welcome.
Thank you, Chairman. Ladies and gentlemen, I'm sorry, I just my report is just handling the science objective rather than strategy. I will talk about the 5 topics. First is the background on the second, I will talk about the science objective of the Chinese deep space explorer, what the general objectives, and then I will talk about the science for the Mars asteroid system. In the science man, all the science objectives are focused on the 5 topics. The first is the origin and the early evolution of the solar system. The second is the life information in and beyond the solar system. And the third is the effect of small bodies activities on the Earth. And the fourth, the effect of the solar activities on the space development. And the last, comparative study of the solar system bodies. China will take the serious scope and study the exploration on other planets besides the Moon. Our exploration will be from the higher start point called the overall planning of scientific objects and the development of deep space exploration. Instead on the Moon and Mars exploration, we will be commenced the science exploration of small bodies, tracking system, and so on. For the main science objective to Chinese deep space exploration before 2030. The general science, according to the key science issue and starting from the Moon and Mars, we will explore the asteroid and the Jovian system. And the general science space exploration will be focused on 3 points. First is the extensive result about the solar system technology and the evolution. The second is the effect of the solar and the small bodies activities on the Earth. The third is the terrestrial life information and so on. To establish a whole system for science research and promote the development of astronomy, space science, and space technology. For the Mars exploration, we focus on 3 aspects. First is investigate the Mars groundwater and the soil characteristics, study the life information and the habitability, and explore the Mars atmosphere. And the second is investigate the Martian physics field, atmosphere structure and composition, and meteorology. Compare them with the Earth's magnetic magnetic field and the atmosphere and the climate evolution. Instead, we will study the effect of wind, water ice, volcano, impact, and the tectonics and the Martian morphology. To read the Martian geology and the evolution and the carry out the comparative planetary science. For the asteroid exploration, we will study and monitor the asteroid orbit and the variation, which will cause potential threat to the Earth and assist the position of the impact to the Earth. We will remote side things and in situ investigate the morphology, structure, lunar and the physical field of the center asteroid. And also we will want to explore the space environment of asteroid and the space weather, and study the interaction of the solar wind and the asteroid. And we want also to sample return and analyze the asteroid sample and study the information, the evolution of the asteroid knowledge and the solar system. For the Jovian system and the planet flyby exploration, we want to take the magnetic sphere and the interaction of solar and the magnetic field and the Jupiter and its moons. And also we want to detect the interplanetary solar wind structure, ionosphere, and its variation, to study the general circulation model and the dynamical mechanism of the Jupiter. And we want to select the moon as a target to detect the surface of morphology, lunar, physical field, and the space environment of Jupiter 3, Ganymede, and maybe other moons, as well as the formation and the evolution of Jovian system and the small bodies. For the Mars exploration or general science objectives for the Mars, when we focus on 4 aspects. The first is to explore the landing site and the environment and the habitability of the life. The second is study the soil characteristics and its water ice content. And the third is study the Martian atmosphere and the environment. The fourth is study the geology, characteristics and the evolution, and the comparative planetology. For the first mission is one orbiter and plus a landing rover. Chinese first mission will be focused on 5 science objectives. First is to study the morphology and the geology structure, including the global topography and the morphology of the high resolution for morphology and the date of the hydro region, and study the formation of the evolution of the geologic structure. The second, we will focus on this studying the surface of oil characteristics and the water ice distribution. For example, the soil head, gradually sediment, and the water ice. The third, we will study the multi-surface material components, either the rocking types and the secondary lunar and the lunar component. The fourth, we we will study the characteristic of the ionosphere, climate and environment, including the space environment and the surface temperature, barometer, pressure, wind field, and the ionosphere structure, and the season change of the surface weather. The first set of objectives is to study the phase field and the interior structure. For example, the magnetic field and the interior mass distribution and the gravity field. Some payload we have a concern. For example, for the orbiter, we will have some 7 payload, because the medium resolution camera, high resolution camera, mass subsurface exploration radar, mass mirror spectrometer, mass magnetometer, mass ion and neutral particle analyzer, and mass energy particle analyzer. For the rover, we choose the topographer camera, multispectral camera, and the subsurface detector radar, mass surface computation detector package, and the mass management field observation station, and the mass climate station. For the second mission to the Mars, it will be a sample return. We focus 2 science objectives. First, the investigation of the land site, just to investigate the sampling background, to investigate the morphology and the geological background of the land site, and audit the in situ analyze state related to the mass samples, and related them to the laboratories assisted data. The second science objective is to analyze and research on the mass samples. Just study the mass samples systematics and continuous, to analyze the structure, physical characteristics, and the contents of the mass soil and the minerals, to investigate the mass formation and the evolution history, and study the comparative quality. The first topic is just science objective to the asteroid exploration before 2030. Before 2030, with the method of the flyby, company attachment and the sample return, Chinese asteroid exploration will carry out the whole exploration, with regional exploration and the sample return of a target asteroid. The science includes to measure the physical parameter of target asteroid, such as orbit element, rotation parameter, and the size. The second is for the asteroid itself, to detect the morphology, surface interior component, interior structure, space weather, near space environment, and the possible water and the organic manipulation of the asteroid. We're studying the asteroid formation and the environment, and they provide information field for solar system origin and evolution. The third science objective to return some asteroid samples, analyze and study the sample deeply and systematics and comprehensive. We will measure the physical characteristics, chemical and mineral organic components, explore the composition and the structure of the samples, and the scientific evaluation for the asteroid origin and evolution. And we also measure the formation ages of the samples to study asteroid formation size, impact fission, and the motion in the planetary space. Very important just to compare the sample with the meteorite, contract the relationship between the meteorite and the asteroid, between ground observation and the remote and the in situ detector, and the laboratory measurements. So it intended the research of asteroid and the solar system origin and evolution. The payload is just conceived. Maybe we will carry some morphology analyze, topography measurement instrument, maybe some composition analyze, interior structure analyze, planetary physical detector and space development analyze. The fifth objectives for the Jovian system and the planet flat exploration. The Jovian is a mini solar system and very important for research the evolution, origin and evolution of the solar system. Chinese Jovian system exploration will take the way of optical survey and focus on the magnetic sphere structure and the Jovian 3 surface, meteor and space development. The general objective will be studying the magnetic sphere structure of the Jovian system into the Jovian itself and the Jovian 3, because the Jovian 3, the Ganymede is the only moons in the solar system have the magnetic sphere. The second is studying the atmosphere model of Jupiter and the Jupiter 3. For example, the magnetic sphere, plasma, and the atmosphere, and the space development and the atmosphere evolution model. The second, we focus on the Jupiter 3 to study the morphology, interior components, and the tectonics of Ganymede. To alter the detection date of Ganymede morphology, components, and the tectology, and analyze the topography and the morphology, geology structure, and the lunar components. And maybe we can study the ice layer as well as its evolution. The fourth, we will study the solar wind structure and the interplanetary magnetic field of the Venus, Earth, Jupiter, and the Kuiper fields. Because we just use Venus, Earth planetary system plan, so we have a chance to study the interplanetary magnetic field and Venus, Earth, Jupiter, and the Kuiper field, and the solar radiation structure and the evolution. The payload is just very close to concise. For example, the planetary physical detector, space development analyze interior structure and the morphology analyze for topographic measurement treatment and material composition analyze. So the main science objectives of Chinese deep space exploration before 2030 maybe junior science maybe employed, starting from the moon and the Mars exploration. Then we will explore the asteroid, Jovian system, and so forth. Science objective focus on the solar system origin and evolution, extraterrestrial life information, discuss the effect of the small body activity on the Earth. This will push forward Chinese astronomy, space science, and technology. All the science and the design just under discussion and the decision. Thank you very much.
So let's start the discussion session. I will exactly what's the format. I suppose okay, let's start with okay, I just want to say a few words on this one, and I also want to thank IAF that I have the honor to be here on this panel. And I think for robotic exploration for the next 2 decades, I think it's very important. And if you look at the history, and I have been with the European Space Agency for 30 years, and if you look also what NASA is doing, is that the good thing we can agree on is that the scientific objectives come from the science community, that they are more or less identical. The priorities are shifted a little bit, but I think they will agree, and I think that's a very good basis for collaboration. And there is one theme that we have defined in Europe for our long-term program, and that's one of the topics is, and one of the objectives is to understand how the solar system works. And to understand how the solar system works also leads to us to understand how life has formed in the solar system. I think that's very important, and that some of the missions, and it was mentioned here, the mission to Europa in the Jovian system, and there's now another object that's further away, and that works for China with the technology. The next step is then to go to the Saturn system with Enceladus, where we have fantastic results, that there is a source where we have water, and this will also help us to understand what does that mean, because if you want to have life in the planetary system, you need water. That's one of the 3 conditions, and therefore one of the objectives is to research or follow water, which was one of these buzzwords. I think it's very important, and the mission, if you have in mind, this is really complementary to what is done by other space agencies. I hope that we can also collaborate on this. And I want to bring 2 points into it, and which works is not seen, because this is one of the hot fields we have right now. These are the fields of exoplanets, to understand the planetary system around other stars. And so many have been detected, and there's nearly every month there's some new wonderful result coming up. To understand how these systems work, and also to really get a feeling if life could have evolved there. What I want to say, we have to understand what happens in front of our door. We have to understand our solar system, that we can try to draw conclusions on other systems. And this has, over the last, it's a new field, over the last 20 years, exoplanets has expanded. It's really fascinating. But we should also say we have to understand here how our system works. And this is fascinating, that the exploration will help us to understand how the system works, how we get involved, and also why we are here on Earth. And I think that's also for the young people, it's a very fascinating field to really work on, to do the science. This is from the science side. There are a few other things we can discuss which go on the technology. I just wanted to make this statement, and I'm really impressed what you plan to do, and it's really great that we get, so to say, complementary research, complementary missions going on, and which really open, the door is open, but really make us to collaborate in the future.
question to ask. When you say documentary, is flying go to Iceland more or less traveling now? Is that out about Iceland?
Yeah, what has been, we know that in ESA, the mission that's called CHOOSE, to study Ganymede and then also Europa, that has been approved, and there's a launch date set in 2020, but hopefully that this can be kept. There's also the Europa Clipper in the States that's been finally approved, but there's a next step, which was the idea originally that at least one of these missions, or it should have been a joint big undertaking between NASA and ESA again, that there should be a lander to put on Europa, which is the next step, you would say, and this is still open. Yeah? There is still an opportunity to do that, but this is something I think one of the space agencies right now, they can't do it alone. There should be collaboration. There is an example, there is a proposal in the ESA system for a lander from my colleagues, and I think that is fascinating that you explore some of the aspects, but it's like always what you do first, you want to see how the objects fly. So you do the flybys. So you know what it is. You do the flybys, then you do your orbital missions, and in the end you land on it. Because from the orbit you get the surface structure and you know where to land. I think it's a bold step that you orbit and then land. Yeah, but you see, I was for long years was a project scientist for Rosetta, and I was the mission manager in the end before I retired. And on Rosetta it was the same. You know, we had a mission to go to a comet, and when we started the first studies, we had no idea how the comet environment really looked like. You know, the first the ideas were old, but we, so to say, got the kick-off that we could study this in '85. The first close-up image of a comet we got in 1986 with the Giotto and the Vega flybys. That was the first image of one comet nucleus. And then you study, you design something where you want to land, and something where you don't know the density exactly. The environment in the end was slightly different. If you look at the Rosetta, the Churyumov-Gerasimenko shape was also different to what you expect. And then you need your talent in navigation, in the flight dynamics, that they can provide, so to say, the framework that you can land as a small object on such a small probe on such an object. And it's the same when you want to land something on Europa, because we know the surface from have great images from Voyager still and newer ones, and but the environment we know to some extent. We know the radiation environment there, which is challenging. And the other thing what a lot of people forget is if you want to go to an object where you believe there is a lot of water, where there might have been a chance that some life has evolved, you have to think about planetary protection. That means you have to put there a very clean spacecraft. You want to bring a sample back on Mars, it's the same. You have to look at planetary protection, which requires more effort to get the spacecraft clean also on the return. And some of my colleagues and some engineers don't like it because the cost goes. Yeah, because if you have a clean spacecraft, it's not so straightforward. And these are things you have to keep in mind, but there the international community is really working on it. We have via Coast Guard, we have a committee where everybody is involved to see what we can do now and what we can do there. And also we have with the Coast Guard very strict rules. And I think that's very important that the community works together, because if you put a rover on Mars and it's a very dirty rover, you might disturb your own measurements if you want to study the composition of the soil, if you are looking for extent or extinct life, and that you don't want. But you also could spoil other agencies' science. And I think there it's very important that we, on the international level, agree on common rules.
Thank you so much for your excellent presentation, Dr. Lee. Have you seen the movie The Martian? So Chinese supported the NASA so long way, so helped the movie star to go back to the Earth. For example, the NASA did not decide the landing methodology because they don't want to contaminate the Mars environment. And your presentation, according to your presentation, you talk about the landing and landing site and the whole environment. Have you decided the landing site and then landing methodology? And also, I'm talking about the collaboration, international collaboration. Your plan seems the independent way, not only NASA but also ESA and all the other agencies. They have a plan to go to Mars, and last month NASA announced that NASA will send the people to the Mars in 2033. Your plan is also about the 2030. So what is your plan for the international collaboration, including Korea? Thank you.
Thank you. The landing site for the Mars, for the Mars exploration, we have some ideas, some choice, but not decided finally. Yes, we just wait to find some chance to cooperate with ESA, maybe Cosmos, maybe NASA, but it's very difficult. So we just I want to learn something from ESA because the Mars Express have a task to land in Mars, but it's very okay. You know, plus your landing site choice may be very useful for us. Thank you.
As to the landing sites, I think that it's important that we say it's complementary. That perhaps not everybody goes to the same site. Yeah, no, but this is very important because there are so many, and I know there was big discussion where NASA first, or NASA put the rovers also where the ExoMars rover will go. There, a lot of science can be done, and Mars is a big object. And you know, if you look at this spot, I think it's somebody should first go to the other one, and that is, I think it's very important that not everybody goes. That this is discussed, and also that one exchange. So we say the science discussions that lead to a landing site, and then sometimes this is forgotten. I have sometimes the impression, a lot of things are discussed and it's in one group, and then 5 years later you discuss the same, because people getting old, and I've been around in space research, I could say, for a long time, and as you said with Mars, and I mentioned planetary protection, when I was much younger. At that time, people were very optimistic. There was the idea that about this year, that we had, say, 50 to 100 missions to Mars. Yeah? That was the optimism, that we have a lot of missions, and then we have to take care of this and this, and that we could have perhaps also human exploration of Mars today. But the reality is unfortunately different. The reality is, budgets are on top, and more driven. We are more driven by money first than by ideas. There are abundant ideas, but there's not always the finances. And I think a lot what was discussed this morning of the International Space Agency, and somebody, and I think Mr. Legal made this remark also on the budgets. I think also what we realize in the collaboration with other space agencies is sometimes that the budgetary environment is different. And it's not always fitting in there, because if the collaboration with NASA we had for Rosetta, we started with NASA, and then NASA had to drop out because their budget frame changed. And then one agency would be 2 years ahead and the others late, and this is sometimes it's an obstacle that you have different budget regimes and they are not running in parallel. Also delivering instruments, if you deliver instruments, and we see that in Europe. Sometimes some countries they can't fund it right away, and you get delays, and these are things you don't want to have in space research. And I think there you have a big advantage in China that you can so to say, direct that more centrally. Because you are funding it, NASA also funding the instruments, so it's easier for them sometimes. And that's what's also easier for you if you select instruments that you can put the pressure on them. And ESA, we have the problem, ESA provides the spacecraft in the science program. In the science program, the instruments are funded by the national governments, and it's sometimes very difficult to say, there must be more money if there's a development. And I think that we have to think as well. These are small issues which are, it's great for collaboration, but we have to see how that in practice can work.
Dr. Lee, I have a question about the status of the objectives of the program that you outlined. Can you tell me, for example, does the entire plan have high-level approval? Does it all have budget, or do only some of the earlier parts of the program have budget? And a related question is, do you have all the technology that you will be needing for this all lined up? For example, do you need new launches, spacecraft process?
Exactly, we have not yet it's the budget, but maybe it's very near. For the technology and the engineering, I think we have 10 years for more than 10 years for the lunar exploration, and there's a very many difference. But I think our storage of the technology will be very. We will get the Mars exploration and the asteroid exploration.
Dr. Lee, regarding the asteroid mission, do you have any outlines for this? I understand that GNF at Purple Mountain Observatory has one outline which goes to, I think, hypothesis in 2025. Is this being considered, or are there rival outlines being developed elsewhere in China? Thank you.
Any opening and the idea is just under discussion. We have not decided the target and the lunchtime and how to do. It's always under discussion.
Today's presentation I'm very impressive, and my comment is Korea will make that big Moon and Mars environmental vacuum chamber. It's a dirty vacuum chamber, about the 50 cubic meter, 4 meter by 4 meter by 4 meter, and then with the soils. So you can test it, you can test the rover and lander, and then the 10-8 hole, and minus 150 plus 150, and radiation, and also many things you can test it. So please don't make a bigger, vacuum chamber and using the Korean vacuum chamber. NASA will use it, and so please advise us together and then make all vacuum chamber or use all the Moon and Mars researchers. That's just comment.
Maybe I think there is no problem.
That's also something. I don't know. Maybe.
Vacuum chamber is with the soils and the plus the surface.
Oh, with the soil.
Yeah, it's not in.
Oh, okay. I said. All right.
Nothing there.
I think that's a very important point, that we are not wasting resources for these things. We should concentrate. We had for also simulation experiments for the common environment with a lot of dust. Where we are lucky that DLR had an old vacuum chamber which we could use because we could put dirt in. Otherwise, they don't like it. And that was an old chamber which unfortunately disappeared, but it was also 2.5 meters diameter, which is excellent. because then you can build up some simulation instruments and you can really work with it. And that helps, and I think that we got from DLR, so ESA didn't have to pay for it, we supported the instruments. But it's also, if you do experiments in there, we realized that perhaps at that time, the group and I was also involved, we didn't publicize it too much and publish too much on this one. And then when you went to you go to the conference 10 years later, and then all of a sudden people say, oh, there are some results. And I think that's important, that this is also public. What you do, that you promote this, and I think that it's really excellent.
I'm Michel Blanc from Beijing and Toulouse, France. As Gershon knows, I'm very interested in going to the satellites of Jupiter in particular, and one of the objectives is to look for life here. So my question is, when we speak of making a program for Mars exploration or for Europa, Enceladus and so on, is there a plan in China in particular to specifically develop an astrobiology committee? Because you know it's very important that at some point in the future you have the community that will push for the instruments and then for the missions. Thank you.
We try to find some sense objective for the life information. Many scientists have many suggestions. We just have a consideration.
From what I understand, actually a lot of the science studies, including astrobiology, is just in the beginning stage of being developed in China. I know a few people working on it in Hong Kong and some mainland institutes. So these are all, in fact, planetary science is something in China really is being developed.
Professor Shen-Kuang in Hong Kong.
Yeah, Shen-Kuang. This is my classmate. Yeah. Another question?
Okay, maybe any more comments?
Thank you.
Okay.
Thank you very much.
Thank you.